All right, so we are at that time. Thank you everyone for joining. My name is Jacob Hayden, and I'm the program coordinator for SaferSim at the University of Iowa. SaferSim is a Tier 1 university transportation center with the research priority of promoting safety, and our webinar series features the research projects from within our center. So thanks for joining us today. There will be time at the end of the presentation for questions and discussion. So attendees, feel free to use your microphone or the chat box to participate. And you can use the chat box at any time throughout the presentation as well. We will hold those questions or comments till the end. And with that, I will like to welcome our presenters from the University of Massachusetts-Amherst, Cole Fitzpatrick, Francis Tainter, and Ganesh Mangalore. Thanks.
All right. So thank you, Jacob, for the nice introduction. So today we'll be going over our project, which we recently completed, the minimum time to situational awareness during transfer control under varying levels of task load. So that's a really long title, one of the longest in my short career to date. But we'll get into what that means in just a minute here. As Jacob mentioned, I'm Cole Fitzpatrick, and alongside me on this presentation will be Francis Tainter and Ganesh Mangalore. Also, Dr. Michael Nodler, Dr. Anuj Pradhan, and Dr. Sibi Samuel also contributed to this project at various stages. All right, so real quick, I'll quickly get into the research questions and what motivated this project and speak a little about the background. Pi will jump in with the study design and the methods. Francis will touch on the results and conclusions, and then hopefully we can get into some spirited Q&A at the end. So our overarching research question was, is the minimum transfer control time that's been previously found to be sufficient still sufficient while the driver is distracted during the automated mode? Or in other words, does the presence of distracting non-driving tasks diminish their ability to retake control and perceive hazards? So previous research that's been conducted at UMass and elsewhere has found that the kind of accepted transfer of control time to be in the 6 to 8 to 10-second range, and there's varying levels in the literature. But one of the studies that we based ours upon has been one that did not use any distracting conditions. It just the driver was alert during automated periods, and they were given 8 seconds to retake control, and that was found to be sufficient. So we wanted to introduce distracting tasks during the automated mode because, as we all know, if cars can drive themselves, we're probably doing something else with our time, even though we probably shouldn't be. So that's the crux of our study here: is can drivers still retake control despite distraction during automation? All right, Pi.
Hi, everyone. So the design of the study had the following 3 distraction tasks as well as no task, which was a control condition. It involved an active visual task, which was playing solitaire on an iPad, a passive visual task, which was reading excerpts from a particular book, I think, or a paragraph, basically just reading it on an iPad, and an active auditory task, which was a mock cell phone task, which recited out few sentences which may or may not have made sense, and the participant was directed to name the subject, object, and tell us whether the sentence made sense or not. So those were the various tasks. Next slide. And the study was a within subject design. Basically, there were 8 drives featuring 8 different hazards. They were a pedestrian crossing the roadway, a car pulling out from a parked position, a person obscured in front of a parked truck, cross traffic, a pedestrian in the middle of the roadway, a roundabout, a construction zone, and also another car that was pulling out of a driveway. from a not from a park position, but just out from an obscure driveway. Um, and the distraction condition and the hazard and the order of the hazards presented were counterbalanced. And we also used the NASA TLX questionnaire after each and every scenario. Next slide. So basically, the NASA TLX questionnaire collects um, 6 levels of task workload, and then the part two of the questionnaire looks at individual weighting for each of these subscale subscales of the workload, basically. Next slide. So among the population recruited, we had about 14 males and 7 females, among which 7 males had prior simulated experience and 4 females had prior simulated experience. Their average age was around the same, somewhere around 2021, and they had about 4 years of driving experience. Next slide. And the transfer of control scenario is basically where uh, in the particular order when the participant would start driving the scenario, and then they would get an alert to engage automation, after which they would engage the automation. Then the off-road glancing, they would be probably off-road glancing, um, uh, performing their task basically, and then they would receive an alert to disengage, after which they would disengage, and then we would see that if they detected the hazards or not. Next slide. And in order to understand their eye tracking, their eye movements, we use a software known as Boris, which is freely available online. 4 reviewers blindly scored each video for various different metrics derived from eye movements. But based on inter-rater reliability, we only found that off-road glance duration and binary coded hazard anticipation had higher reliability, and hence we decided to go forward with those two eye movement related metrics. Next slide. And this is Francis.
Awesome. Yeah. So thanks, Pi and Cole. I'm going to touch a little bit on the results. I'm going to break this down into 2 sections. So first here, looking at the NASA TLX scores. So like Pi had alluded to, the breakdown was across the 6 different types of workloads. So on the x-axis, you have the mental, physical, temporal demands, the performance, effort, and frustration. And then along the y-axis, you have their mean ratings across our participant group of the NASA TLX survey. And then from left to right within each of those sections, you have each of the tasks by color. So you have the active task, which Pi had mentioned was playing solitaire on the iPad that was mounted within the cab. The visual task, which is the reading task on that iPad within the cab. The audible task, which was to mimic a cell phone task, and then the control. So across the board, as you can see from this graphic, there was a significant increase of task load across all of the non-driving tasks when you compare that to the no task. And then with regard to the audible task specifically, there was a higher score in 5 of 6 of those categories when compared to the control. Specifically looking at the physical demand is the only one that, as you can presume, would not have that higher score. And then lastly on this slide, more again along the lines of that audible task, or I'll refer to it as the mock cell phone task, there was a significantly higher mental and temporal demand exhibited from that task specifically with regards to the results of our NASA TLX, which, just as another reiteration, was performed after every drive that the participant performed within each of their experimental drives. Next slide. So the next step here is to look into just the off-road glances for each of the occupants or participants. And so across all 4 of these tasks, we see a trend that we hypothesized from the get-go, right? So from the visual tasks, both active and passive, where the drivers are predominantly looking within the cab at the iPad, they had a much higher percent of time off-road glances as compared to the mock cell phone task, the auditory task, as well as the control, which had a much lower mean off-road glance time. Next. But the interesting thing to note here, so regardless of the data that was presented on that previous slide, there was, despite all those visual attention differences during the automated driving condition, the hazard perceptions were not significantly different across the board. So this graphic on the left, you see the 4 tasks broken down, and then the y-axis presents that percent of occupants or participants that perceived the hazard once they disengaged automation. So across the gamut within the 3 tasks and our no task, there was not a significantly different change in terms of actually perceiving the hazard that was presented to them. And so just to wrap this all together, like I just mentioned to, and as Cole and Pi alluded to, the visual and audible tasks elicited a much higher workload. And as I had highlighted on that slide, the audible task had a much higher mental and temporal demand presented to them according to our NASA TLX survey. With regards to that off-road glance time for each of the tasks, the drivers who were performing that visual task, looking at the iPad, spent on average 30 or more seconds glancing away from the road during the automated driving conditions. But that being said, there was no statistically significant difference with regards to the hazard anticipation between the groups who performed that in-vehicle task and the control group. And then overall, tying it all back together, what Cole mentioned at the beginning of the presentation, looking at the 6-second warning time and whether it is sufficient, we found that it is sufficient for the drivers, regardless of their in-vehicle task or distraction, however you want to call it. They still presented them ample time to perceive the hazard and to retake control of the vehicle before that hazard came into play. So the 6-second warning time was sufficient as a conclusion of this study. And so I know that was a short but sweet presentation, I hope, but at this point, I think be happy to field any questions that you might have.
So we'll give people a minute to either raise their hand in Zoom or type in their questions in chat. One thing I did want to highlight, and maybe something that if we could go back and do it differently, may have skewed the results, is we did present the drivers with an alert as to the hazard that was going to present itself. So it would be interesting if the alert was not present to see if that hazard anticipation still held up across the distraction conditions.
Excellent, thank you. Well, as they mentioned, we do have some time for questions, thoughts, and comments. While we're thinking on that, I'll just thank everyone for attending, first of all. This presentation will be available within the next couple days on our YouTube channel and on our website. So feel free to share it with anyone that's interested once we send that out. I have a question in regards to your participants. You mentioned their age and their previous simulator experience. Do you know if any of them had experience driving automated vehicles, or I guess any familiarity with assistive features in cars?
I don't believe so. Pi Francis, do you know if we captured that on our questionnaire? Given the average age, I would guess no. One potential caveat to that answer is the people who do have the prior simulator experience potentially experienced automation within our driving simulator. But chances are they probably didn't have actual automation experience. And then our age did skew younger, and that was twofold. So one, we were looking at distracting conditions, and we know that younger drivers are more prone to distracting behaviors, and also just the ease of recruiting on a college campus.
Thank you. Okay, well, we'll give it a couple more moments here. Here we have a question from participant. Thanks for the presentation. Participants were able to perceive hazards, but did you assess situation awareness?
So we know hazard perception and anticipation is uh, more or less a function or component of situation awareness. So we were going along those lines in terms of situation awareness, but we did not use traditional methods to gauge situational awareness, such as SART or SAGAT. We just looked at hazard anticipation and off-road glances for this experiment.
I know we are working on getting this final report posted online, so that will be available here within a couple, hopefully by the end of the week. I know if anyone's interested in more information, they can reach out to me or Cole and the research team to actually answer those questions or actually go into that report and look at that a little more. Excellent, thank you. And I guess with that, I'm not seeing any other questions. Like I said, if you do have any thoughts or comments, please follow us up with us afterwards by email. We will send this recording out afterwards. If the report is available by then, we'll include it as the link. I will also put in a link for the registration for our next webinar, which will feature research from the University of Iowa. This will be on Tuesday, May 18th. We will be sending registration information around again in the next couple weeks, so look out for that. And with that, I think that's all we have. So thank you for your time, and we will see you at our next webinar. Thanks.